All right. The Learning Commons is really busy today, so I'm hoping the microphone's not picking up everybody outside my office. But now what we're going to do is up at a level. Now we're going to include oxygens and hydrogens, and we're going to balance in what we call an acidic situation. To do this, you're going to follow a rule called major hydroxide, which is that you're going to balance your majors, then you're going to balance your oxygens, then your hydrogens, and then you're going to balance for charge. So, first step, we are going to balance the major atoms. That is everything other than an oxygen and a hydrogen. So if you look up here, we have S2 going to an S. So I'm going to put a coefficient of 2 in front of the HSO3 minus. Then you're going to balance the oxygen atoms. Now, I find this really fun. To balance oxygen, you get to just add waters. So however many oxygens you need, you add that many waters. So if you look at this one, I have 8 oxygens on the left, and I have 2 times 3, 6 oxygens on the right. So I'm going to add another 2 oxygens so that I have the same number of oxygens left and right. And I'm allowed to just do that. So I add 2 waters. But now this throws off your hydrogens. So now you're going to balance the hydrogens by just magically adding hydrogen ions. So if we look at the left-hand side, there is no hydrogens. But on the right-hand side, we have 1, 2, and then another 4. We have 6 hydrogens on the right. So we add 6 hydrogen ions on the left. In the next part, you're going to balance for charge. So for this one, you're looking for the total ionic charge left and right. So on the left-hand side, I have a charge of -2 plus 6 is going to give me a total ionic charge of +4. And on the right-hand side, I have -2 and 0, which is a total ionic charge of -2. So to balance this out, I'm going to add 6 electrons on the left so that my charge on the left is 4 minus 6, which is -2, and it's balanced with the right. Kind of fun. I don't know. I love this. I like the first lesson, goes on and on and on for me, whereas this, I'm like, okay, feels a little bit more mathy or something. All right, let's give them a go. So this first one, we have MnO4 minus going to Mn2 plus. First thing you're going to balance is majors. Mn on the left, Mn on the right, good to go. Second thing I'm going to balance is my oxygens. I have 4 oxygens on the left, so I'm going to add 4 waters on the right. Now I've thrown the hydrogens out of whack. I have no hydrogens on the left. I have 8 hydrogens on the right, so I'm going to add 8 hydrogens on the left. Then I need to balance for charge. So my charge on my left-hand side is 8 minus 1, which is +7. And on the right-hand side, I have a charge of +2 plus 0, which is just +2. To balance this out, I need to subtract 5 so that I have an overall charge of +2. And the way that I do that is I simply add 5 electrons onto the left-hand side. Now, if you want to, and you want to make it look more like the table, you can feel free to rearrange this and write it as MnO4 minus plus 8 hydrogens plus 5 electrons forms Mn2 plus 4 waters, but you do not have to. And the nice thing about this is I think this is one of my reactions. There it is. I already have it circled. MnO4 minus plus 8 hydrogens plus 5 electrons forms Mn2 plus and 4 waters. So sometimes they ask you to do one that's already on the table, but we can now do it from scratch. All right, what about this next one? So the next one, again, balance for majors, Ru, I think this is rubidium. Then I'm going to balance for oxygens. So there's 2 oxygens on the left. So I'm going to add 2 waters on my right. Now I have no hydrogens on the left and 2 hydrogens on the right. So I'm going to add 2 hydrogen ions on the right. And now I have to check for charge. On the left, I have +2 and then a 0. On the right, it's all 0. So I need to -2 to bring my total ionic charge to 0. So I'm going to add on 2 electrons. And I'm going to leave it like that. All right, hopefully you're feeling a little bit confident with this and give the next 2 a go, or maybe you don't need them, totally up to you. So for this one, balance your majors. I always forget to balance the majors, so I have to say it over and over again. Then I balance my oxygens. So I have 2 on the right, now I have 2 on the left. Then you're going to balance your hydrogens. I have 4 on the left. Now I have 4 on the right. Then I'm going to balance for charge. So this is +2 on the left and +4 on the right. I need to go down by 2 to make my total ionic charge the same. And I'm going to do that by adding 2 electrons. All right, last one has no majors. This one is already balanced for oxygens, so I get to just add the 2 hydrogens. Oof, I'm out of space. Poor planning, Karen. Okay, and then on the left-hand side, I have an overall charge of +2. On the right-hand side, I have an overall charge of 0. So I need to go down by 2, that they're the same. And to do that, I'm going to add 2 electrons. I'm just going to write that nicer. So O2 plus 2 hydrogens plus 2 electrons forms H2O2. Awesome. Okay, hopefully you can practice a bunch of those because we're going to go one step beyond these for the next video. So make sure you practice these before watching the one to put them in a basic situation.